Hello all. In this video, I'm going to talk about descriptive statistics and also a distribution. So here we will understand what are all those methods comes under a descriptive statistics and types of a distributions. Let's not say types of a distribution. We are going to cover in another video, but one of the important distribution we are going to understand in this video. In the previous video, we have discussed about types of statistics. So let's understand in the each type. So what are all the things we are going to talk about? So what are the things that we can consider as a descriptive statistics and inferential statistics? All right. So if I talk about a descriptive statistics, so basically it is a first one is a measure of central tendency and measure of dispersion, right? So what is a measure of central tendency? Like if I have a data, right? So what is basically the data tendency, right? Which side or how the data looks like, right? So that is basically the measure of central tendency. And if I talk about the types or what are the types that we can say that, okay, it's a measure descriptive statistics in terms of a measure of central tendency. It is nothing but a mean and median, right? We have seen what is mean and what is median. So these are basically measure of central tendency, mean and median, right? So it's just a name given. So how we can measure basically the data tendency, that kind of a thing we can measure with the help of a mean and median that we have discussed in detail in the earlier video, right? So fine, let's execute that. It's just like how we have done. So here you can simply assume that I'm going to generate some random numbers, random integers, starting from 30 to 35, and I need 10 random integers, right? It's a part of a NumPy. With the help of NumPy, we'll be able to generate 10 integers, right? So, and storing all the data in an X variable, and I'm using that X variable to find the mean. So, and yeah, this is what is the basically the mean data, and the median is basically 32, right? So yeah, randomly I'm generating instead of hard coding. I have generated randomly and use that data to find the mean and to find the median. This is basically measure of central tendency. And what is the measure of dispersion? So as I was saying in the earlier video that we will discuss this variance and standard deviation with the help of formula. As you can see, the formula basically with respect to variance is what is given here, right? Summation of I equal to 1 to n, xi minus mu whole square divided by n. So what is x here? X is basically a data. As you can see, x is a data, and mu is basically mean, and n is number of occurrences, right? So say that I have a data here, x 2, 4, 8. All right. So this is basically x data. You can have many number here or any variable. With respect to that variable, we will have a data, right? So basically 2, 4, and 8 are x data, this guy. And what is mu? Mu is basically mean. So if I consider only these 3 data points, so I can say 2 plus 4 plus 8 by how many data points? 1, 2, 3, right? 3. So my mu is going to be 6 plus 8, 14 by 3. It is basically 4 point something, right? 4 point, say that 4.6, around that number, right? Uh, so 4.6 is my mu, right? So then how I'm going to interpret this? So mu we got, x we have already, and n is basically number of occurrences. How many times? I mean, how many occurrences? 1, 2, and 3. N equal to 3. So now you can simply place that, and you will get the variance. All right. So that is how I will be able to get. And behind the scene, so I don't need to manually do all this calculation. So what I'm going to do, I'm going to just use a np.var. That is going to get a variance. So x minus mu for this 2 minus mu and 4 minus mu, 8 minus mu whole square. And basically this is a summation plus plus, all right, divided by 3. All right. So that is basically the variance. And a standard deviation, you can say just a square root of a variance. Dot std is what I can use to get the standard deviation, right? Either you can find the standard deviation, and variance is basically square of the standard deviation. Variance equal to std square, or you can find a variance and take a square root. Both are same. All right. So yeah, so here we are trying to understand the measure of dispersion. Dispersion is basically how much data is dispersed, right? How much data is dispersed from the mean. So that is basically measure of dispersion. How the data is varying. What is the standard deviation? How much data is deviated? So those kind of terms we call it as a measure of dispersion. And variance and standard deviation are the dispersion terms. All right. So yes, now let's understand a quartiles. What is quartile? Now say that I have some data here, 10, 20 up to 80, right? So how to understand these quartiles? So I'm using some pandas and trying to convert that into some data frame. And what I'm doing here, I am trying to say that dot describe. I'm using this dot describe method to understand the quartiles. All right. So I can say dot describe, and this is going to give me basically, sorry, I will take out this. This is going to give me this quartiles and different stats, right? So how to interpret? So what is a count here? So count is basically how many counts I have. So I have totally 8 counts. 1, 2, 3, 4, 5, 6, 7, 8. So 8 counts. And what is the mean? We know what is mean, right? So all addition and divided by number of counts. So that is also I'm going to get. And what is the standard deviation? We have seen a standard deviation here. So that standard deviation also I'm going to get. And what is the minimum number? Yes, we have a minimum number. What is the 25th percent of this data, entire data? Say 10, 20, 30, 40, 50, 60, 70, and 80, right? Assuming this is 100%, assuming this is 100% data, right? So in that, I'm going to get the 25th percent of this data. So if I take a 25th percent, so it is going to be 27.5. Let's say it's a quarter. And this is the 50th percent, 50th percent of my data, right? Assuming this is 100%, and within that, what is the 50th percent? That data also I'm going to get, and 75%, right? So that also I'm going to get. And what is the maximum number? Yes, this is the maximum number, right? So here I'm going to call, this is the first quartile, and this is the second quartile, and this is the third quartile, right? So this is how I will be able to interpret, and all these stats I will be able to get with the help of dot describe method. So you have to use your data set dot describe. So I can use any data set and I will be able to describe, and this is going to give me a data set stats. One thing to remember, so dot describe method will work on only numerics, numerical data, not on the categorical data. All right. So for the categorical, we have some other methods, but yeah, if we just use a dot describe, it is going to consider only the numerical data. Any features, suppose say X, Y, and Z, or let's say that age, height, weight, and if I say gender, gender is male and female. So here we'll have a number, height will have a number, weight will have a number, gender will have a male and female. So when I use the dot describe method, it is going to give me stats of only these three features or three columns or these three variables, whatever you can call it. So it is not going to give any details about the gender because it is a categorical data, categorical column, categorical variable. All right. Okay, so let's move on. So now, when should I call a interquartile? There are some things like terms that we usually use in the statistics, interquartile. So whenever I say interquartile, it is basically Q3 minus Q1. So this is basically Q1, Q2, and this is a Q3. So Q3 minus Q1. So the resultant data is basically resultant quartile is basically what we call interquartiles, right? So then quartile range, if I talk about what is the quartile range, it's maximum minus minimum, maximum minus minimum, then remaining terms what we left, this is basically quartile range. So that's how you can interpret, right? So this one we already discussed, interquartile range. All right. Now let's understand a distribution here. So how to understand this distribution. So as of now, we'll just talk about some only a normal distribution and some skewed data, things like that. All right. So if you look into this systematic symmetric distribution, so the data is basically symmetric. When I say symmetric, so if somebody is talking about a symmetric distribution and all, then you should understand that the mean, a median, and mode always equal. Right? We know mean, we know median, we know mode also. Right? Somebody is given a huge data, suppose say x equal to say so many data points, thousands of data points, lakhs of data points. If the data distribution looks something like this, right? We call it as a bell-shaped curve. So in that case, the mean and median and mode will be equal. So if that kind of a situation, then we call it as a symmetric distribution, right? This is one type of a distribution. And if somebody is saying that, okay, data is skewed. So if somebody said, okay, skewed data means which skew, what type of a skewness it has, a right skew or a left skew, right? So if somebody says right skewed, then you can see this curve is slowly making a slope here, but it is not a symmetry, right? It's not balanced on both the side. So right side it is a little bit skewed. So it is called as a right skewed data. Similarly, so if the data is skewed on left hand side, we call it as a skewed left. So what kind of a situation we can assume in this case? right? So let's say that let's take student marks. So student marks most of the time, assume that there are thousands of students. So, any particular section or in any particular level or class, whatever you can assume, 10th class or 12th or B or whatever it is. So if I take all those data points, marks, right, all these numbers, so marks will be like how not all the students will get the same number. So slowly, some people are basically start from zero also, a 1 also, and it can reach up to maximum number, suppose 100 marks, right? So if I take all this data, right? So 0, 1, 0, 1, 0, 5, 0, 6, 0, 8, 10, 10 again, something like this, right? If I take all these data points, all these marks and plot it here, if it's a symmetric distribution, it looks like this. It means that if I take an average of all this data, all these marks and plot it, and average will be somewhere here, mean data. And if I take the center data point, the median mass, that also will be staying in this position, this number only basically. And if I take a mode, and most of the most frequently occurring marks are basically the mode, and that mode will be always equal to median and mean, right? Starting from 0, 1 and things like that and up to 100 here. So in between, suppose assume that it is a 50, right? So yeah, most of the time, most students will get marks around 50 range, maybe 45 to 55, things like that, right? So in this case, it is a symmetric distribution. So how to interpret those marks in a skewed right diagram? Say that only less students, suppose I start from 0 to 100 here, very less students have secured marks above 70, 70, 80, and 90, and it is 100. So from here on, the students are very less who secured marks greater than 70. As and when it starts moving in the a higher direction, I mean, in the higher level, 70, 80, and 90, and 100, as and when it keep on increasing, the number of students are going to be very less. And in this case, most of the students might have failed here. Suppose it's a 0 and 10, 20, and 30, right? So some of the students have failed here, and very less students have got a more number of marks or more than 70. And if I consider more than 90, it's very, very, very less, maybe 1 or 2 or 3%, right? I'm just giving a number here. So that's how you can interpret. In this case, skewed left. So starting from 0, it is 100. So here you can say that, okay, if I make this as a 70, and we can say that there are more number of students have secured marks greater than 70, right? And yeah, here very less students have secured um, 10 marks, and here it is a 20 marks, and here it's a 30 marks. However you want to interpret, you can interpret that way. So here it's a less count, as and when it is increasing, the number of data is basically frequency is increasing. That is why you see that mode is it's on the right direction, extreme right. All right. So that's how you can interpret. So in terms of a salary, very less starting from 0, very less number of employees are getting a salary up to this range, maybe 30K, something like that. So however you want to interpret, you can interpret. All right. So that is about a distribution, skewed right and skewed left. I will talk more about types of a distribution in the upcoming video. Yeah, that's all in this video. Thank you for watching this video. See you in the next video. Keep learning. Thank you.